Prepare to witness an automotive revolution that could send shockwaves through the electric vehicle industry. Toyota's CEO has unveiled a game-changing engine that threatens to disrupt the EV dominance as the world races toward electrification. Could this innovation derail the EV revolution? Are we on the brink of a seismic shift in the automotive landscape, or is this just another bold claim in the competitive world of car manufacturing? Let's explore the evolution of Toyota's engine technology. As Toyota stands on the precipice of a new era in automotive technology, its journey is nothing short of remarkable. From humble beginnings to the cusp of revolutionizing the industry, Toyota's evolution in engine technology is a testament to innovation, perseverance, and foresight. In the earliest days, Toyota's foray into engine development was characterized by engines that were simple yet effective for the times. But, did you know that during World War II, Toyota primarily manufactured standard-sized trucks almost exclusively for the Army? This period was crucial for Toyota, laying the foundation for its future in automotive engineering. Post-war, Toyota began to diversify and refine its engine technology. The company's venture into gasoline engines marked the beginning of a journey toward more complex and efficient designs. In the 1950s and 1960s, Toyota introduced engines like the R-Series, which were notable for their durability and reliability. These engines powered some of Toyota's earliest successful cars, setting a standard for the brand's commitment to quality. Fast forward to the 1990s and early 2000s, a period marked by, significant advancements. Toyota introduced the 7AFE lean-burn engine, which was honestly a pioneering effort in reducing emissions. The development of the variable valve timing intelligent mechanism in engines like the 2JZGE represented a really big leap in both fuel efficiency and performance. And then, the turn of the millennium saw Toyota delve into hybrid technology, with the development of the 1NZ-FXE, the world's first engine for gasoline-electric hybrid vehicles. These innovations really underscored Toyota's commitment to environmental sustainability, long before it became a global trend. In the past decade, Toyota has not only continued this legacy, but has, honestly, significantly accelerated it. The introduction of the Dynamic Force engine family brought engines that delivered exceptional fuel efficiency without compromising performance. This engine family, powering models like the Corolla and Camry, really showcases Toyota's ability to combine fuel efficiency with performance, a feat that's not easily achieved in the automotive world. But what about the present? As we stand in 2024, Toyota is on the verge of a breakthrough that could, really redefine the automotive landscape. The company's latest endeavors in hydrogen-powered internal combustion engines and the development of water-powered engines represent a bold departure from conventional automotive powertrains. These technologies are radical reimaginings of what powers our vehicles. Think about it, an engine that emits only water vapor, harnessing the most abundant element in the universe, hydrogen. The implications are honestly staggering. This isn't just about reducing emissions or improving efficiency, it's about completely rethinking how vehicles impact our planet. And well, the mystery that surrounds these new technologies only adds to their allure. How will these engines perform in real-world conditions? What will it be like to drive a car powered by water? The answers to these questions could very well change our entire understanding of what it means to drive. As we anticipate Toyota's next big reveal, one thing is certain. The automotive industry is on the brink of a revolution, and Toyota is leading the charge. Toyota's hydrogen-powered internal combustion engines. In a world where electric vehicles are, increasingly becoming the norm, Toyota's foray into hydrogen-powered internal combustion engines emerges as a real game-changer. But what exactly sets this technology apart from the traditional gasoline engines and electric vehicles we've become accustomed to? The crux of Toyota's innovation lies in the use of hydrogen as a fuel for combustion engines. But why hydrogen, and how does it work in an internal combustion engine? Unlike hydrogen fuel cell electric vehicles like the Toyota Mirai, which generate electricity through a chemical reaction, hydrogen internal combustion engines, or HICEs, burn hydrogen directly in a manner akin to gasoline engines. This direct combustion method has a unique advantage. It produces almost zero carbon dioxide emissions. The only significant byproducts are trace amounts of engine oil burned during driving and some nitrogen oxides due to the intake of oxygen from the air. However, these emissions are considerably lower compared to traditional internal combustion engines. Have you ever considered the performance capabilities of an engine running on hydrogen? The answer lies in the engine's design. Toyota modified its 1.6-liter turbocharged 3-cylinder engine, commonly found in models like the GR Yaris and GR Corolla, to accommodate hydrogen fuel. This included the integration of a robust fuel tank for high-pressure hydrogen storage and a re-engineered fuel supply and injection system. Interestingly, hydrogen combustion occurs faster than petrol, offering the potential for a highly responsive engine, a trait particularly beneficial in motorsport applications. But what about the real-world applications of such an engine? Toyota has been proactive in testing and refining this technology in the demanding environment of motorsports. The Corolla Sport race car, equipped with a hydrogen-powered G16E GTS race engine, has demonstrated impressive performance metrics. Lastly, what is Toyota's ultimate goal with this technology? It's not just about creating a new type of engine, it's about envisioning a sustainable future. Toyota aims to achieve carbon neutrality by 2050 and sees hydrogen combustion engines as a crucial step in this direction. The company's commitment goes beyond just automotive applications, encompassing collaborations to address challenges in green hydrogen production and infrastructure development. This multifaceted approach underlines Toyota's belief in the potential of hydrogen as a key element in the transition to a carbon-neutral society. So, by combining the familiarity of traditional engine designs with the environmental benefits of hydrogen, Toyota is not just challenging the current EV-centric narrative, but is also redefining what sustainable transportation can look like. As the automotive world pivots towards sustainable technology, Toyota's hydrogen-powered internal combustion engines present a fascinating proposition, but how exactly do these engines stack up environmentally, especially when compared to hybrid electric vehicles and plug-in hybrid electric vehicles? Let's delve into this question and unravel the environmental benefits of hydrogen engines. Firstly, what makes hydrogen engines stand out in terms of environmental impact? The key factor here is their emission profile. Unlike traditional gasoline engines, which emit a significant amount of carbon dioxide, a greenhouse gas contributing to global warming, Toyota's hydrogen engines produce zero CO2 emissions during operation. The primary emission from these engines is water vapor, making them an incredibly clean alternative in terms of greenhouse gas emissions. But is it really possible to have an engine with such minimal environmental impact? Yes, it is. The secret lies in the combustion process of hydrogen engines. When hydrogen fuel is burned in these engines, it reacts with oxygen from the air to produce energy, with water vapor being the only byproduct. This process starkly contrasts with the combustion of fossil fuels, where carbon in the fuel combines with oxygen to produce CO2. The elimination of CO2 emissions from the tailpipe is a significant step towards reducing the automotive industry's environmental footprint. But how does this compare to HEVs and PHEVs? HEVs, which combine a gasoline engine with an electric motor, and PHEVs, which can be plugged in to charge their batteries, offer improved fuel efficiency and reduced emissions compared to conventional gasoline vehicles. However, they still rely on gasoline and, therefore, produce CO2 emissions during operation, albeit at lower levels than traditional vehicles. In contrast, hydrogen engines offer the potential for true zero-emission driving as long as the hydrogen fuel is sourced sustainably. Another environmental aspect to consider is the life cycle emissions of these vehicles. While hybrid electric vehicles and plug-in hybrid electric vehicles have batteries that require rare earth elements and often involve energy-intensive manufacturing processes, hydrogen engines avoid these challenges. The production of hydrogen fuel, especially when derived from renewable sources like wind or solar power, can be less environmentally taxing than battery production, offering a more sustainable overall life cycle. One of the first questions that arise is, how does Toyota manage to maintain the engine's performance while switching to a completely different fuel source? The key lies in the hydrogen combustion process. Unlike gasoline, hydrogen requires different handling and combustion techniques. The engine employs a high-pressure hydrogen direct injection system, which is a significant departure from traditional fuel injection systems. This system allows for precise control of hydrogen delivery into the combustion chamber, optimizing performance and efficiency. But how does this impact the engine's overall performance? Remarkably, the 1.6-liter engine manages to deliver power and torque figures that are competitive with its gasoline-fueled counterparts. The turbocharger plays a vital role in this, ensuring that the engine delivers the necessary boost for high performance. But, is turbocharging enough to handle the unique properties of hydrogen? The challenge with hydrogen is its low density compared to gasoline. This characteristic necessitates a larger volume of hydrogen to achieve the same energy output as gasoline. Toyota's engineers have tackled this challenge head-on, ensuring that the turbocharger and other engine components